Section 15.3, Deployment Pipeline Production Stage. We started implementing a deployment pipeline back in Chapter 3, and we have come a long way since then. We've automated all the steps from code commit up to having a release candidate ready for production. There are still two operations that we have performed manually so far: updating the production scripts with the new application version and deploying it to Kubernetes. In this section, we'll start looking at the final part of a deployment pipeline, the production stage, and I'll show you how to implement it as a workflow in GitHub Actions. Section 15.3.1, Understanding the production stage of the deployment pipeline. After a release candidate has gone through the commit and acceptance stages, we are confident enough to deploy it to production. The production stage can be triggered manually or automatically, depending on whether you'd like to achieve continuous deployment. Continuous delivery is a software development discipline where you build software in such a way that the software can be released to production at any time. The key part is understanding that the software can be released to production, but it doesn't have to. That's a common source of confusion between continuous delivery and continuous deployment. If you also want to take the newest release candidate and deploy it to production automatically, then you would have continuous deployment. The production stage consists of two main steps. 1. Update the deployment scripts, in our case the Kubernetes manifests, with the new release version. 2. Deploy the application to the production environment. Note: an optional third step would be to run some final automated tests to verify that the deployment was successful. Perhaps you could reuse the same system tests that you will have included in the acceptance stage to verify the deployment in a staging environment. The next section will show you how to implement the first step of the production stage using GitHub Actions, and we'll discuss some implementation strategies for the second step. We'll aim to automate the whole path from code commit to production and achieve continuous deployment. Section 15.3.2, Implementing the production stage with GitHub Actions. Compared to the previous stages, implementing the production stage of a deployment pipeline can differ a lot depending on several factors. Let's start by focusing on the first step of the production stage. At the end of the acceptance stage, we have a release candidate that's proven to be ready for production. After that, we need to update the Kubernetes manifests in our production overlay with the new release version. When we're keeping both the application source code and deployment scripts in the same repository, the production stage could be listening to a specific event published by GitHub whenever the acceptance stage completes successfully, much like how we configured the flow between the commit and acceptance stages. In our case, we are keeping the deployment scripts in a separate repository, which means that whenever the acceptance stage workflow completes its execution in the application repository, we need to notify the production stage workflow in the deployment repository. GitHub Actions provides the option of implementing this notification process via a custom event. Let's see how it works. Open your catalog service project, catalog service, and go to the acceptance stage.yml file within the .github workflows folder. After all the acceptance tests have run successfully, we have to define a final step that will send a notification to the Polar deployment repository and ask it to update the catalog service production manifests with the new release version. That will be the trigger for the production stage, which we'll implement in a moment.
Listing 15.17, Triggering the production stage in the deployment repository.
With this new step, if no error is found during the execution of the acceptance tests, a notification is sent to the Polar deployment repository to trigger an update for catalog service. By default, GitHub Actions doesn't allow you to trigger workflows located in other repositories, even if they both belong to you or your organization. Therefore, we need to provide the repository dispatch action with an access token that grants it such permissions. The token can be a personal access token, PAT, a GitHub tool that we used in Chapter 6. Go to your GitHub account, navigate to Settings, Developer Settings, Personal Access Token, and choose Generate New Token. Input a meaningful name and assign it the workflow scope to give the token permissions to trigger workflows in other repositories, Figure 15.6. Finally, generate the token and copy its value. GitHub will show you the token value only once. Make sure you save it since you'll need it soon.
Figure 15.6, a personal access token, PAT. granting permissions to trigger workflows in other repositories.
Next, go to your Catalog Service repository on GitHub, navigate to the Settings tab, and then select Secrets, Actions. On that page, choose New Repository Secret, name it dispatch_token, the same name we used in listing 15.17, and input the value of the PAT you generated earlier. Using the Secrets feature provided by GitHub, we can provide the PAT securely to the acceptance stage workflow. Warning! As explained in Chapter 3, when using actions from the GitHub Marketplace, you should handle them like any other third-party application and manage the security risks accordingly. In the acceptance stage, we provide an access token to a third-party action with permissions to manipulate repositories and workflows. You shouldn't do that lightheartedly. In this case, I trusted the author of the action and decided to trust the action with the token. Don't commit your changes to the Catalog Service repository yet. We'll do that later. At this point, we have implemented the trigger for the production stage, but we haven't initialized the final stage yet. Let's move on to the Polar Deployment repository and do that. Open your Polar Deployment project, Polar Deployment, and create a production stage.yml file within a new .github workflows folder. The production stage is triggered whenever the acceptance stage from an application repository dispatches an app_delivery event. The event itself contains contextual information about the application name, image, and version for the newest release candidate. Since the application-specific information is parameterized, we can use this workflow for all the applications of the Polar Bookshop system, not only Catalog Service. The first job of the production stage is updating the production Kubernetes manifests with the new release version. This job will consist of 3 steps. 1. Check out the Polar deployment source code. 2. Update the production customization with the new version for the given application. 3. Commit the changes to the Polar deployment repository. We can implement those 3 steps as follows.
Listing 15.18. Updating the image version upon a new application delivery.
That's all we need for now. Commit and push the changes to your remote Polar deployment on GitHub. Then go back to your Catalog Service project. Commit your previous changes to the acceptance stage and push them to your remote Catalog Service on GitHub. The new commit to the Catalog Service repository will trigger the deployment pipeline. First, the commit stage will produce a container image, our release candidate, and publish it to GitHub Container Registry. Then the acceptance stage will fictitiously run further tests on the application and finally send a notification, a custom app_delivery event, to the Polar deployment repository. The event triggers the production stage, which will update the production Kubernetes manifests for Catalog Service and commit the changes to the Polar deployment repository. Figure 15.7 illustrates the inputs and outputs for the 3 stages of the deployment pipeline.
Figure 15.7. The commit stage goes from code commit to a release candidate, which goes through the acceptance stage. If it passes all the tests, the production stage updates the deployment manifests.
Go to your GitHub projects and follow the execution of the 3 stages. In the end, you'll find a new commit in your Polar deployment repository, which was submitted by GitHub Actions and contains a change to the Catalog Service production overlay so it uses the newest release version. Perfect! We just got rid of the first of the 2 remaining manual steps, updating the deployment scripts with the newest release version. We still have to apply the Kubernetes manifests to the cluster manually using the Kubernetes CLI. The second step of the production stage will take care of automating the application deployment whenever a new version is promoted to production. That's the topic of the next section. Polar Labs. It's time to apply what you learned in this section to Edge Service, Dispatcher Service, and Order Service. 1. Generate a PAT with a workflow scope for each application. It's a security best practice not to reuse tokens for multiple purposes. 2. For each application, save the PAT as a secret from the GitHub repository page. 3. Update the acceptance stage workflow with a final step that sends a notification to the production stage with information about the newest release candidate. 4. Push your changes to GitHub, ensure the workflow is completed successfully, and check that the production stage workflow in the Polar deployment repository is triggered correctly. Edge service is the only application available through the public internet, and it requires an additional patch to configure the ingress to block requests to the actuator endpoints from outside the cluster. You can get the additional patch from the Applications/Edge Service/Production folder within Chapter 15/15End/Polar Deployment. For simplicity, we accept that the actuator endpoints are available without authentication from within the cluster. Internal applications like Catalog Service are not affected, since their actuator endpoints are not accessible through Spring Cloud Gateway. On the other hand, the Edge Service ones are currently accessible via the public internet. That's not safe in a production environment. A simple way of fixing that is configuring the ingress to block any request to the /actuator/ endpoints from outside the cluster. They will all still be available from within the cluster so that the health probes can work. We are using an Nginx-based ingress controller, so we can use its configuration language to express a deny rule for the actuator endpoints. In the source code repository accompanying the book, you can check the final results in the Chapter 15/15End folder. See this link.